Hello students, in the previous video I discussed with you about alkanes. Here I am going to discuss with you about alkenes. We know alkenes have the general formula CnH2n and alkenes are unsaturated hydrocarbons. We know they are unsaturated. They have a double bond between two carbon atoms, carbon to carbon double bond. They are also known as olefins. The simplest example is ethene. We have the structure of ethene here. C double bond C and then two hydrogens on each carbon. Let us see how we can prepare ethene. Okay. Number one method in your syllabus is the dehydrohalogenation. What is dehydrohalogenation? Removal of what? Hydrogen halide. One hydrogen and halogen is removed. So how can we do that? Alkyl halide is heated with concentrated alcoholic solution of caustic potash. Caustic potash is potassium hydroxide. Alcoholic solution is the potassium hydroxide is a solid. It is dissolved in alcohol. Instead of water, it is dissolved in alcohol. That is alcoholic solution. It reacts with alkyl halide. So example, we can take ethyl bromide. So here we have ethene is obtained by dehydrohalogenation of bromoethane. Okay, bromoethane or ethyl bromide. So we have KOH which is boiled and then we have ethanol also. It is ethanolic. Okay, because ethanol is a solvent here. Now here you have bromoethane, otherwise called ethyl bromide. This hydrogen and this bromine is removed by this. It will form KBr and H2O. The potassium hydroxide reacts, right? And the remaining carbons get linked because these elements are going out. This will link. So there is a double bond coming here. So ethene is formed. So this is how it is obtained. Or you can write it in the simplest form if you don't want to follow this. CH3CH2Br plus KOH alcoholic on boiling gives CH2 double bond CH2 ethene plus KBr plus H2O. So this is a simple way of writing. You don't have to memorize if you understand this, or if you find it difficult, follow this. Any one of that you can write. Okay. Then the second method is by dehydration. Dehydration is removal of water molecule. Okay. Ethanol is dehydrated. We take ethanol here by using concentrated sulfuric acid. Temperature is 170 degrees Celsius, or instead of ethanol, so sulfuric acid, you may take anhydrous aluminum oxide, but the temperature needs to be higher, 350 degrees. Then ethene will be obtained. See the reaction. Ethanol is taken, CH3CH2OH ethanol or ethyl alcohol, concentrated H2SO4 170 degrees Celsius, or anhydrous aluminum oxide at 350 degrees Celsius, 350 to 500. Here you have ethene formed and water removed. Removal of water, that is dehydration. You want to understand what is exactly happening? Here is ethanol. Two carbon atoms and one OH. So ethane, one all are ethanol, right? So these are dehydrating agents, these substances, CON H2SO4 or anhydrous aluminum oxide. They are known as dehydrating agents because they help remove water molecule by chemically combined water. Remove this. So this H and OH goes as water. The remaining double bond is established here. Ethene is formed. So this is how you get ethene. It's a colorless gas with a pleasant odor. Okay, that is about ethene. Now what are the reactions of ethene? It is an unsaturated hydrocarbon, so undergoes addition reaction. So we need to understand the kind of addition reactions happening to ethene. So let us see. First of all, addition of hydrogen. Now hydrogen can be added across the double bond in the presence of catalysts such as nickel at 300 degrees Celsius. Ethane is formed. Here is ethene. As I said, ethene, C double bond C, hydrogen and hydrogen and hydrogen and hydrogen. This is ethene. Okay. Now there is sufficient number of hydrogen atoms are not there. So when you put a hydrogen here, one hydrogen goes to this, one hydrogen goes to the other carbon. So what you get here, H2 is added, nickel is catalyst. So C, single bond C. So there are sufficient number of hydrogen getting added to it now. So two hydrogens less, now that hydrogen has come. So it becomes, this is C2H4, this is C2H6. This is ethene, this is ethane. This is unsaturated, this is saturated. Okay. You got it? Ethane is formed. Now next is addition of halogen. Halogen is chlorine, bromine, iodine, etc. So I'm taking the example of addition of bromine here. Now halogen can be added when ethene is passed through a solution of the halogen in a neutral solvent such as carbon tetrachloride. Example, a solution of bromine in carbon tetrachloride. It has a purple color. Bromine is colored. We know bromine is a red colored liquid. When it is dissolved in CCl4, carbon tetrachloride, the color is purple. Now when ethene is a gas, we pass the gas through the solution. The purple color disappears because bromine in the solution gets absorbed and finished. So it becomes colorless. Solution turns colorless. Since the purple color changes to colorless, it can be used as a test. So unsaturation, this is a test for unsaturation. This observation is obtained when any unsaturated compound is passed through a solution of bromine in carbon tetrachloride. What is the reaction? CH2 double bond CH2 is ethene, Br. Okay, example, I will make it like this: C double bond C, E, H and H. Okay, this is ethene. Okay, now bromine is Br2 is Br. There is a covalent bond. Now this breaks, so one bromine goes here and the other one goes here. So what you get here is C single bond C, H, 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 and here you have Br and Br. The bromine comes here. The double bond is broken and so it is formed. So this is eth, 2 carbon atom. Eth, primary suffix ene. No, it is ane. Ethane. Substituent is there, carbon 1, 2. 1 there is a bromine, 2 also there is a bromine. So 1, 2 dibromo ethane is the product. 1, 2 dibromo ethane. Okay, substitution. Sorry, this is addition reaction. Now what are the uses of ethene? It is used in oxyethylene flame. Ethene common name is ethylene. Oxygen and ethylene together can burn and form a torch of high temperature of 2800 degrees Celsius. Oxyhydrogen flame you must have heard. Similarly, this is oxyethylene flame, which can be used for cutting and welding of metals. And then artificial ripening of fruits. Raw fruits can be converted to ripened one, or they can be ripened by keeping them in an atmosphere of ethene. This increases the shelf life of the farmer. Example, mangoes, which when they are fully mature, if you pluck them, they will decay in 2 or 3 days. But before maturity, they are plucked. Artificial ripening is done using ethene. So the color appears, but it does not decay for at least 7 days. So the shelf life is increased. The farmer gets a good price. So it comes to the market. So it can be stored for some more days. So that is the advantage of artificial ripening. Then for the preparation of compounds such as ethylene glycol, dimethyl ether, PVC, etc. So for these are also uses of ethene. So that's all in this. Thank you.